Good evening to everyone. In today's class we will discuss about the input resistance of a differential amplifier. It is defined as the equivalent resistance at either of the input terminal by maintaining the other input source to 0 or by maintaining the other input terminal to ground. So for example, if you want to find out the input resistance at the first terminal, we should maintain the other input terminal to ground. That means other input source to 0. That is V into is equal to 0. And the equivalent resistance is equal to the ratio of input voltage at the first terminal to the input current at the first terminal, that is Vn1 by Ib1. And similarly, if you want to find out the input resistance at the second terminal, we should maintain the first input terminal voltage to 0, that is Vn1 is equal to 0, and the equivalent resistance is equal to the ratio of input voltage at the second terminal to the input current at the second terminal, that is Vn2 by Ib2. So here we are finding the input resistance at the first terminal, that is Ra1 is equal to Vn1 by Ib1 by maintaining Vn2 is equal to 0. We know Ib1, that is base current, is equal to the ratio of Ie1 by beta Ac. Substitute this value in this equation, then Vn1 by Ie1 by beta Ac by maintaining Vn2 is equal to 0. And already we know the value of Ie1. So that is Ie1 is equal to Vn1 into Re plus Re minus Re into Vn2 by Re plus Re whole square minus Re square. Substitute this value in this equation. And finally we can get the value, that is Vn1 by beta Ac by Vn1 into Re plus capital Re minus capital Re into here we are maintaining the other input voltage to 0, that is Vn2 is equal to 0. So that is capital Re into 0 by, if you expand this term, that is Re plus capital Re whole square, then we can get Re square plus capital Re square plus 2Re into Re minus Re square, and Re square will be cancelled, and here we can also cancel the values of Vn1, and finally we can get the value of Ra1 is equal to beta Ac into Re square plus 2Re into capital Re by Re plus capital Re. In these two terms we can get the common value of Re. So that is beta Ac into small re into small re plus 2 into capital Re by Re plus Re. We know the difference of capital Re and small re. Capital Re is the emitter resistance and small re is the internal emitter resistance. If you compare these two values, capital Re is very much greater than small re. So that is Re plus 2Re is approximately equal to 2Re only. Re plus Re is approximately equal to capital Re only. And finally Re beta Ac into Re into 2 into capital Re by capital Re. If we cancel the Re terms, Ra1 is equal to 2 beta Ac into Re. This is the input resistance at the first terminal, and similarly we can also find out the input resistance at the second terminal. So that is Ra2 is equal to Vn2 by Ib2 by maintaining Vn1 is equal to 0. So by applying the same procedure, that means substitute the values of Ib2, that is Ie2 by beta Ac. Already we know the value of Ie2 from the previous classes. Substitute Ie2 value also. If you simplify this value, and finally we can get the value, that is Ra2 is equal to 2 beta Ac into Re. So that is Ra1 is equal to 2 beta Ac Re. Ra2 is also 2 beta Ac Re. So for the dual input balanced output configuration, the input resistance at the two terminals will be same. And similarly we can also find out the output resistance of DIBO configuration. Output resistance is defined as the equivalent resistance that would be measured at either of the output terminal with respect to ground. So in balanced output configuration, we are taking the output between two collectors. So that means we are considering two output terminals. So hence we have two output resistances, that is RO1 and RO2. And at both the output terminals we have only output resistance as capital RC. So that is RO1 is equal to capital RC. RO2 is also equal to capital RC. So this is the case for the balanced output configuration. For the unbalanced case, we have only one output resistance because we are taking the output at only one collector with respect to ground. So this is the output resistance of DIBO configuration, that is dual input balanced output configuration. Next, properties of a differential amplifier. Here we are comparing the properties of four types of differential amplifier configurations. So that is, we have mainly four types of configurations, that is dual input balanced output configuration, dual input unbalanced output configuration, single input balanced output configuration, and single input unbalanced output configuration. So in this column we can draw the related circuit diagram for the corresponding differential amplifier. In this case, we have two inputs and the output is taken between two collectors. For the second case also, we are applying two inputs and the output is taken at one collector with respect to ground. In this case, we are applying only a single input and the output is taken between two collectors. And in this case, we are applying a single input and the output is taken at one collector with respect to ground. And for the DIBO configuration, the differential gain is capital RC by small re. And for the second case, the differential gain AD is equal to RC by 2RE. Already we know the value of AD, that is differential gain for the dual input balanced output configuration in the previous classes. From the previous classes, by applying same procedure, we can also determine the values of differential gain for the remaining three configurations. So that is, in this case, the differential gain is RC by 2RE. For the third case, differential gain AD is RC by small re. For the fourth case, differential gain AD is equal to capital RC by 2RE. And the input resistance for the DIBO configuration is, here we are applying two inputs, that means we can have two input resistances, RA1 and RA2. RA1 is equal to 2 beta AC RE, RA2 is also equal to 2 beta AC into RE. In this case also we are applying two inputs, so we can have two input resistances, RA1 RA2, and RA1 is 2 beta AC RE, RA2 is also 2 beta AC RE. For the third case, we are applying only single input and we can have only one input resistance, that is RA1 is equal to 2 beta AC RE. In this case also we have one input resistance, that is RA1 is equal to 2 beta AC RE. And the last column is output resistance. For the balanced output configuration, we are taking the output between two collectors. Hence we have two output resistances, that is RO1 is RC, RO2 is also RC. In this case we have only one output resistance because here we are taking the output at one collector with respect to ground, that is R0 is equal to RC. In the balanced output configuration, we can have two output resistances, that is RO1 is equal to RO2 is equal to RC. And in this case we have only one output resistance, that is R0 is equal to RC. Thank you.